So in this class, the next lesson will be, next topic will be electric field at a point due to dipole on the perpendicular bisector of the dipole. Perpendicular bisector of the dipole. Perpendicular bisector means on the equatorial line. On the equatorial line of the dipole. So question can be asked, derive an expression for the electric field due to the dipole at a point on the equatorial line of the dipole. Or equatorial line means perpendicular bisector of the dipole. So what I'm going to do is, I'm going to draw an electric dipole. Electric dipole means a system of two equal and opposite charges separated by a certain distance apart, say 2a. Now let's do like this. Let's say minus charge Q is placed at A. Okay, is placed at A. And charge, okay, minus Q charge is placed at A. And plus Q charge is placed at B. Let O be the center of the dipole. Distance of A from the center of the dipole is your small a. Distance of B from the center of the dipole is also your small a. Now what I'm going to do is, I'm going to draw a perpendicular bisector on the dipole. So I'm going to draw perpendicular bisector on the dipole. Alright? So I want to find out the electric field at any point P, say, on this perpendicular bisector. Okay? So let this P be at a distance x from the center of the dipole. Now the electric field, okay, at P will be the resultant electric field due to plus Q at P and due to this minus Q, no? So there will be two electric fields acting at P. One is due to this plus Q, which is placed at B, and one is due to minus Q, which is placed at A. Now, the electric field at point P due to this plus Q will act along this direction. See, we know that the electric field due to a positive charge is directed outwards. So the electric field at P due to this plus Q will act along this direction. It will act outwards. So this one will be your EB. And the electric field at P due to plus Q will act in this, or the electric field at point P due to this minus Q, no, will act in this direction. So this will be your EA, because the electric field due to a negative charge acts inwards, no? Okay. Now what I'm going to do is, let this angle be theta. Let this angle be theta. Then due to symmetry, this angle will also be theta, right? That is due to symmetry. Now through this point P, I'm going to draw a line which is parallel to your AB. Okay, which is parallel to your AB. So in that case, since this angle is theta, so this angle will also be theta. Now again, since this angle is theta by symmetry, no? So this angle will also be theta. Is it okay? Now, EB acts in this direction. EB is acting along this direction. Okay? So we can resolve EB into two components. One is EB cos theta and the other one will be EB sine theta. Now, your EB is acting along this direction. If the component of this EB along the theta, means along this line, okay, EB makes an angle theta with this line. So the component of EB along this direction will be EB cos theta. Now you make a perpendicular to this EB cos theta. So this is a line, okay, perpendicular to this EB cos theta. Then the component of this EB in this direction will be EB sine theta. So we have resolved EB into two components. One is EB cos theta acting along this line, and the other one is EB sine theta acting along this line. Correct? Similarly, we can resolve EA into two components. EA is making an angle theta with this line. So the component of EA along this line will be EA cos theta. And the component of EA along this line, means perpendicular to EA cos theta, will be EA sine theta. Alright? Now EB sine theta, EA sine theta acts along the same line but in opposite direction, so they will cancel out each other. Okay? So the resultant electric field at this point P will be due to this EB cos theta and EA cos theta. Are you getting me? So the resultant electric field at P will be due to EA cos theta and EB cos theta. So plus EB cos theta. Okay. Now here EA is equal to EB. Why EA is equal to EB? Because these charges are equal in magnitude and both the charges are placed at the same distance. Okay. These two charges, they are equal in magnitude, and this point P is placed at the same distance from the two charges, right? So the electric field, that means the electric field at P due to this charge and the electric field at P due to this charge will be equal. So E equal to EB. Therefore, the resultant electric field will be given by 2EA or 2EB cos theta. Are you getting that? Is it alright? So this will be your hint. I think the first video was better, no? Okay. Now, let us find out the electric field at this P due to this charge or discharge. Is it okay? Anyone you can consider. So let's find out the electric field at this point P due to discharge. Electric field at P at this point P due to discharge plus Q placed at B will be given by 1 by 4 pi epsilon naught into Q by square of the distance. What is the distance here? PB. Distance of this point P from this charge is PB. So PB square. Then EB will become 1 by 4 pi epsilon naught into Q upon, we can find PB using Pythagoras theorem over this right triangle. This distance, this side is A, this side is X. So using Pythagoras theorem, PB will be equal to root over X square plus A square. So that PB square will become X square plus A square. Is it okay? Now therefore the resultant electric field at P will be equal to 2 EB cos theta. So 2 times EB means 1 by 4 pi epsilon naught into Q by X square plus A square. We cannot cancel these 2 with 4 because 1 by 4 pi epsilon naught has a fixed value, it's a constant quantity. Alright. And cos theta. From this right triangle, cos theta means side adjacent to angle theta upon side upon the hypotenuse. Right? Cos theta means side adjacent to angle theta, that is A, upon the hypotenuse. Hypotenuse is PB. Your PB is root over x square plus a square. In that case, your resultant electric field will become 1 by 4 pi epsilon naught into q times 2. I'm rearranging this to q and a upon this term multiplied with this term will give you x square plus a square to the power 3 upon 2, because a times square root of a, suppose example, a times square root of a is a to the power 3 upon 2, right? So using that concept. Now we know that electric dipole moment means product of either charge and the distance between the two charges. So q times 2a gives you the dipole moment p. Therefore E will become 1 by 4 pi epsilon naught into p upon x square plus a square to the power 3 by 2. So this is the resultant expression for the electric field at a point on the equatorial line of the electric dipole. But if the length of the dipole is very small, in that case, if a is very small as compared to x, then a square can be neglected. When you compare it with x square. So in that case, your electric field will become 1 by 4 pi epsilon naught into p upon a square is neglected, so x square to the power 3 upon 2, 2 cancels out. So we have 1 by 4 pi epsilon naught into p upon x cubed. Is that alright? Yes. So the next topic is electric dipole. When placed in uniform electric field. Uniform electric field. So electric dipole in uniform electric field. In the last video, we have seen about we have seen some of the properties of electric field lines. There we have discussed what is uniform electric field and how the electric field lines looks like in uniform electric field, right? So uniform electric field means the electric field lines will be parallel, equispaced and straight. So this is your, let's say that this is your uniform electric field E. I'm going to place an electric dipole over here. Is it okay? I can place the dipole. Can I place the dipole in this way? It's alright. No, it's alright. Dipole is like this, like this. Okay. I can keep the dipole in this way, okay? So electric dipole means a system of two equal and opposite charges separated by a certain distance, say 2a. So suppose I have placed minus q at this point A and plus q at this point B. Let O be the center of the dipole. This distance will be A, this distance will be small a, so the total distance will be 2a. This total distance will be 2a. Is it alright? Okay. Now, very important. This is your uniform electric field. It is going in this direction. Is it okay? Now, when you place a positive charge in an electric field, okay, if you place a charge, positive charge in an electric field, it will go along the direction of this electric field E. Are you getting me? When you place a positive charge in a uniform electric field, then the positive charge will move along the direction of the given field. Are you getting me? And if you place a negative charge in a uniform electric field, then it will go towards, it will go away it will go in a direction opposite to the direction of this field E. Are you getting that? A positive charge in a uniform electric field will move in the direction of the given field, and a negative charge placed in a uniform electric field will move opposite to this given field. Are you getting that? Yes. Now, see, we have seen that electric field is defined as force experienced per unit test charge, right? In that case, your force will be given by Q naught times E. Is it okay? That means the force experienced by this charge plus Q now inside the field will act in this direction, right? And the magnitude of the force will be given by Q times E. Q times this field E, right? I don't know, itulah definition is something. Sabi na, suppose this is a source charge. On a space around it, this charge will create a field known as electric field. Now, if you place a test charge inside this field, then it will experience a force, right? Is it okay? Yes. So the electric field will be given by force experienced by this test charge. In that case, force will be given by Q naught times E. We have discussed that in the previous videos, right? Okay. If you're not getting this concept, then you can like search in the YouTube. You can search like electric field introduction, okay, by Samrat. All right. So the force experienced by this charge plus Q placed in this field will act along this direction, will act in this direction towards the charge, towards this field E, given field E, right? And the force experienced will be given by this Q, all right? And the force experienced by this charge minus Q placed inside this field will act along this direction, opposite to that of the given field, and it will be given by minus QE, right? Minus QE, because E means F upon Q naught, right? You replace this Q naught by minus Q, then F will be minus Q times E, alright? Now this is your dipole. Here, this is the most important part. This is the dipole. One force is acting along this way. Another force is acting along this way. Two equal and opposite forces are acting on this dipole. So what will happen to this dipole? Yes, just imagine. You tie a thread on this edge of the marker. You place the marker in this way, on a free space. Then you tie a thread at this point and pull in this direction. You tie a thread at this point and pull in this direction. And you apply equal forces. Then what will happen? This dipole will start to rotate. This dipole will start to rotate about its axis O. Is it okay? Here the center of the dipole O will be the axis of rotation. Itu marker to rakiginik taiti pratanivi with equal force, then it will start to rotate. It will start to rotate about its center of mass. Is it okay? Rotational symmetry. It will rotate about its center of mass. Here the dipole will rotate about its center O. Is it okay? So since this dipole is being rotated, that means it will produce a torque. A torque will be produced. And torque is given by what? Is given by? Torque on the dipole will be given by force, product of force Torque is given by the product of force and the perpendicular distance between the two forces. Product of either force, alright? Product of either force acting at this point B or the force acting at A, okay? Product of either force and the perpendicular distance between the forces. Perpendicular distance between the two forces. That will be your torque. Is it okay? Now, this distance 2A cannot be the perpendicular distance between the two forces, right? So how do you construct the perpendicular force? Okay, let's say that, okay, the length of the dipole, no? The length of the dipole, shall we write over here? The length of the dipole is 2A, okay? So this length 2A cannot be the perpendicular distance, right? Okay. Then the perpendicular distance, how will you construct? Let's, okay. I'm going to make this point as M. Here BM, is it alright? Here BM will be the perpendicular distance between the forces. Are you getting me? This is one force, this is another force, the perpendicular distance between the two forces. See? Alright, perpendicular distance between the two forces will be given by BM. Are you following me? Now let's say that this dipole, since it is placed in a uniform electric field E, it makes an angle theta with it. Okay? Suppose this dipole, this is your dipole, it makes an angle theta with the field. Then this angle will also be theta. Right? This angle will also be theta. In that case, your torque will be F times perpendicular distance means BM. Force, either of the force, I can take any one QE, right? Or you can take minus QE times BM. What is your BM here? In this right, see, if we are assuming that the dipole makes an angle theta with the field E, then this angle will also be E. In that case, right? The angle be E. So in that case, your BM will be in this right triangle, your BM will be what? BM will be, yeah, AB sine theta, right? Okay, in this right triangle, sine theta. In right triangle, ABM abam. Sine theta will be side opposite to angle theta, BM upon hypotenuse AB. So in that case, sine theta will be equal to BM upon twice length of the dipole. So in that case, your BM will be equal to 2A sine theta. There are two ways of doing this question, okay? Doing this topic derivation, I'm teaching you in only one way, easier way. Your BM is 2A sine theta. Now 2A times Q gives you the electric dipole moment, P. So your tau will become PE sine theta. If you express in vector notation, vector tau will be given by P cross E. P cross E. Definition of cross product. Is that okay? If A, B are any two vectors, consider that vector A and B are any two vectors, then A cross B, vector A cross B will be given by magnitude of A, magnitude of B with the sign of the angle between them. And if it is dot product, A dot P will be given by magnitude of A, magnitude of B with the cos of the angle between them. Using this relation, you can find out the angle between any two vectors also. Is it alright? So this is the required relation. This is the relation for the electric dipole when it is placed in a uniform electric field.